Hello students, how are you? Hope you are all in the pink of health. I am Atun Roy and you are watching Bond Making and Bond Breaking channel. Today I will go to discuss with you about two important chemical reaction and its mechanism. First is Kolbe Schmitt reaction and second is Reimer Tiemann reaction. Kolbe Schmitt reaction is used to prepare salicylic acid, and Reimer Tiemann reaction is used to prepare salicylaldehyde from phenol. So without wasting time, let's go with optimistic energy. First reaction is Kolbe Schmitt reaction. First reaction is Kolbe Schmitt reaction. If you have phenol, okay, you have phenol and you want to prepare here salicylic acid. Firstly you should use NaOH. It gives you a product, that is H here and OH here. So water molecule is removed from here, so you get ONA. So firstly you get ONA. Secondly, if you take carbon dioxide, first step, and second step, if you acidify it, okay, acidification. First if you use carbon dioxide, and secondly if you use acidify it or acidification, then you get that is OH, and this is COOH. This is salicylic acid. Okay, phenol to salicylic acid. Now what is the mechanism? Behind it? The mechanism is, firstly we have this benzene, this O and H. Okay, now you use OH minus, which is coming from the NaOH. Now OH and H give you water molecules, so OH minus is formed, O minus is formed. So you O minus you get. Now O minus is starting its resonance, so minus is here, so double bond is broken. So what will you get? You get this is double bond O, this is double bond O, and if you use, I just remove this. Okay, just remove this. So here you get O minus. Here you get O minus. So second, now similarly O minus ready to form resonance. Pi bond is broken here, so pi bond is removed from here. So finally you get double bond O here minus. Now you take CO2 molecules. So minus hit this carbon, which is delta positive, so the bond is broken here. Okay, you take phenol, then you use NaOH, OH and H get together, water molecule is removed, then O shows you minus form, it started its resonance, so it gives its electron, so the pi bond is broken, so minus is formed in ortho position, then minus hit this carbon and O is removed from here, pi electron is removed from here. finally you get finally you get finally you get this is double bond O, this is the bond, and here COO. So this is C double bond O, and one pi bond is broken, so this is single bond O minus, and here the hand is 1, 2 and 3. Carbon has 4 valency, so one hydrogen is here. Okay, now this hydrogen gives its bond, so hydrogen is released from here and hydrogen came to this point, to this minus point. So finally and when it gives, this pi bond is broken, so finally you get double bond, double bond, double bond, O minus, this is O minus, and here COH. Then acidify it by using H plus. When you use H plus come to this point, because oxygen shows you negative. So finally you get salicylic acid. This is OH, OH and COH. Your product is formed. Okay. Firstly you take phenol, then OH. OH and H get together, water molecule is removed. Then you show it negative form, then it starts its resonance. O gives its electron to form pi bond. This pi bond is removed from here, so the minus charge is formed on the ortho position. Then minus is hitting this carbon. Okay, minus attack this carbon, and the pi bond between carbon and oxygen is removed. So oxygen shows negative charge. So finally COO minus. The valency of this carbon 1, 2, 3. So one hand I show it, I could open it like this. Now this hydrogen wants to give this bond, and here the pi bond is formed. So this hydrogen is free. It is negative and it is positive. So negative positive is attracted together. So it forms COOH, and this is O minus. Now take H plus ready to acidify it. So finally you get this product. Okay. This is very important reaction. This is Kolbe reaction or Kolbe Schmitt reaction. This is Kolbe Schmitt reaction, Kolbe's process. This is Kolbe's process. Secondly, now the process is Reimer Tiemann reaction. Okay. Now the process is Reimer Tiemann reaction. For this Reimer Tiemann reaction, the reaction is you have phenol, then then you use CaCl3, NaOH, okay, and some temperature 65 to 75 degrees centigrade, 65 to 75 degrees centigrade. Okay, then you can prepare here OH and CH. This is the reaction. This is Reimer Tiemann reaction. Okay, phenol to salicyldehyde by using CaCl3 and NaOH with the heat 65 to 75 degrees centigrade. Mechanism. You have phenol, so you write this phenol. Okay, you write this phenol. Now, firstly, you should prepare OH minus and H, and here H, this is OH minus, and here you get HCl3 here. OH and HCCl3. Okay. So finally, OH attack this hydrogen and carbon snatch its electron. So you get C, Cl, Cl, Cl. Cl gives you negative form. Now you remove one chlorine from here. As you know, chlorine is a good living group. So CCl2 here located. So you give this product. Okay. Finally, OH minus HCCl3. Then OH attack this hydrogen, so carbon snatch its electron. So carbon form negative charge. So carbon negative, as they snatch the electron on the bond. Then Cl3, carbon negative. Then for the process of neutralizing, then chlorine is removed from here. So you get this product. Okay. You get this product. Now, oxygen ready to form pi bond. Now oxygen ready to form pi bond, and you take here this product CCl2. So this bond is ready. Okay, this bond is ready to attack this carbon. Okay. Now what will you see? From here you will see. This H is removed with OH. Okay. So water molecule is removed from here. So finally you take double bond O as lone pair is given. So double bond O, bond, this bond and this double bond. And now here Cl2, but as carbon snatch its electron, it is minus, and this carbon has 1 bond, 2 bond, 3 bond. So one bond is opened like this. Now similarly, hydrogen gives its bond to form pi bond on the benzene due to the stability, and H is removed from here. So as it is negative, so it comes here, and this bond is removed. So finally you get O minus, and here CHCl2. Now take OH minus. If you remove this Cl2, okay, you should use OH minus. So finally you get this is O minus, and you remove this Cl2 with this OH, so you see OH instead of 2 Cl2, 2 OH, and this is H. Okay. As we know that 2 OH is not possible, so water is removed from here. So the product is CHO, and this is O minus. This is O minus and CHO. Now acidification. Okay, acidification means H plus is given. So H plus goes to this oxygen. Finally you get OH and CHO. This is salicylic. So the mechanism is like that. If you have NaOH, then you write OH minus and HCCl3. OH minus give its electron, and carbon snatch its electron. So carbon minus. Due to neutralizing process, chlorine is removed from here, so the CCl2 is given. Now you take phenol. Oxygen gives its lone pair as OH and H from water molecule. Oxygen gives its lone pair on negative. Then this pi bond goes to this carbon. So carbon form negative charge. Here the carbon has 4 bonds, 1 2 3. So another bond is open like hydrogen. So this bond is ready to donate its bond. So this bond is coming up. So hydrogen is released and hydrogen goes to this minus point. So when this pi bond is formed, so this pi bond should be broken. So oxygen gives you negative charge, and here CaCl2. Now use OH minus instead of Cl2. So OH instead of Cl2. Then here the possibility to remove water molecule. So one water molecule is removed from here. So you get CHO and O minus. Now it's ready to acidify it with H plus. Now H plus and O minus, it's give you a product OH, and this is CHO, salicylaldehyde is formed. Okay, I hope you like this reaction. Keep studying, take care of your health. Okay, if you have any problem, write on my comment box. I will solve. I will try on my level best. Thank you so much. Keep studying.